Good afternoon, boys and girls. It's time to go over our DMA math solutions. It's week 31, day 3. So let's take a look at our first problem. So our first problem has to do with area. And back at the beginning of the year, we of course talked about how area is measured in square units. So if we did not have our squares already provided for us in our rectangle, we could take the length of the side, which would be 4. So that's 1, 2, 3, 4 lengths. And we don't know how long these units are. We could use centimeters, we could use inches. We're not quite sure because it doesn't give us that information. We know that it's 3 lengths wide. So I have 4 rows with 3 squares in each row. So in order to find my area, I know I have 4 rows with 3 squares in each row. So if I multiply the length times the width, so this being my length, this being my width, I can get my square units. So this would be 12 square units. So that's what we're going to place. Now, remember, area is different than perimeter. Perimeter is the length of each one of the sides that make up that figure. So we're not looking for the perimeter, we're looking for the area. How many square units of space it takes to cover the inside of the figure. Okay, so I'm going to erase that. And now we're going to move on to our subtraction problem. So we have our minuend, which is 235. We're starting with 235 as our total. And from that 235, we're subtracting 128. So again, we have several different strategies that we can use. So let's start with the break apart strategy. So we can break apart our place values as 200 minus 100 would give us 100. We can subtract 30 minus 20. So we have to think, can we subtract 20 from these 30? And the answer is yes, we can subtract 20 from 30. That would give us a difference of 10. And then we subtract our ones place. So we have 5 from the 235, and we're subtracting 8. So again, we have to think, can we subtract 8 from 5? No. So what that tells us is we're going to have to borrow or regroup, leaving us with no tens. And we're going to regroup that 10 here as 15. And now we can subtract 15 minus 8, which would give us 7. So we take the hundreds place and the tens, and we don't have any tens, and our ones, and we put it back together as one number, which is 107. Now, we also should remember that we can also check our subtraction by using addition. So to do that, we would take our difference, which is the part that we're missing, add it back to the 128, and that should bring us our total of 235 to be able to check it. Another way that we can use our understanding of subtraction, another strategy we can use is subtract off. So we start with our 235, subtract off 100, which would give us 135. Then we take our tens place and subtract off from the 135, subtract 20 from this 20 here. That's going to leave us with 115. Then we take the 115 and subtract 8. So we have 15 here minus 8. We know that that would be 107. We can also use our algorithm. So in order to do that, we could take our total place that at the top of our algorithm and subtract the 128. Now, same thing. We notice that we cannot subtract 8 from 5. So we need enough to subtract 8 from 5. So we borrow a 10 from the 30, giving us 20. And we regroup that 10 as with the 5 to make 15. So now we have 15 minus 8, which is 7, which is what we had here in our break apart strategy. We have 20 minus 20, which would give us 0, which is what we had here. We just happened to borrow what we had left in our regrouping. And then, of course, we have 200 minus 100, which is what we have here in our hundreds from our regrouping, or excuse me, our break apart strategy, and that gives us 107. So again, we understand that we can use our difference. We can add that back to what we subtracted, and that should give us our total of what we started with. Okay, so now let's move onward to our fraction problems. And if you notice here, I'm going to use them together. And the reason I'm going to use them together is because they just so happen to work together so well. So I'm going to start here with this rectangular figure. So it's one whole rectangle. And what they've done is they've broken it up into 4 equal pieces. So we know our denominator is 4 in each one of these parts, of course. And we are showing each one of these as one of those 4 parts. So 1, 1, 1, and 1. Now when we take those 4 parts together and put them all as one whole, that's of course equal to 4/4. So we know that the shaded portion of this rectangle is 1/4. If we wanted the unshaded section, we would count how many of those unit parts are unshaded. So we have 1, 2, 3. 3 of the fourths are unshaded. Now let's take this information and look at our comparison of the two fractions. So we are comparing a 1/4 amount to a 2/4 amount. So we've already shown that we have 1/4 here. Well, how would we represent 2/4? Well, we would need to shade in another one of these 4th pieces. So let's think about this. If I were to create another rectangle similar to this one, and I used the same partition pieces, and I did 1/4 parts, and of course if I shaded 2 of those 4ths in, we could use the 2 rectangles to compare. So I have 2/4 here and 1/4. So if I compare 1/4 to 2/4, I know that one of the 4th pieces is less than 2 of the 4th pieces. Also, we should also know that 2/4 is also, if you look at this rectangle, we have half of that rectangle colored in. Or we have 2 is half of the 4 pieces for our, so this was also equivalent to half. So if we were going to compare a 4th compared to a half piece, we would know that 4th pieces are smaller than half pieces. So again, that understanding is shown with using a less than sign. So that's day 3 of week 31. We'll do day 4 tomorrow, and have a good afternoon.